Hello students! We are so close to finding a formula for this series here. We know this is the generating function, and we know that we can use the generalized binomial theorem on this piece here. So let's try to do that. You see, I know that if I take x plus 1 to the r, that this is going to be the sum from n equals 0 to infinity of r choose n times x to the n. Okay, so what happens if I have this? Let's just look at the square root of 1 minus 4x. The square root of 1 minus 4x is going to be minus 4x plus 1 to the 1/2. So I can use that right here. I can set r to be 1/2, and I can replace x with minus 4x. So let's do that. So I'm going to get the square root of 1 minus 4x is equal to 1/2 choose n, and this is going to be minus 4x to the n. Okay. Now we actually have a formula for this that we computed earlier in an earlier video, because this 1/2 choose n is not the simplest coefficient. So what I'm going to do is I'm just going to fill in what I have written down from that video without going through the entire construction again. So we got this. We got the sum from n equals 0 to infinity of 2n choose n minus 1 to the n plus 1 over 4 to the n 2n minus 1. And of course, we still have this minus 4x to the n, but I could write it as minus 1 to the n minus 4 to the n x to the n. Okay, well, what does that allow me? Oh, positive 4 to the n. Sorry, I split off the minus 1 already. Okay, so what does that allow me to do? Well, it allows me to do that, and it allows me to cancel this if I make it a negative. So now I have the negative of this sum okay, but that's just this piece. So let's put everything together now. So what I really want is 1 over 2x times 1 minus this piece here. But since this is a negative in front, this becomes a plus, and I'm going to get this right here. 2n choose n of this. Okay. So let's see what this is. And one thing I could do is I could say, hey, look at the very first term over here. The very first term over here, this is going to be 0 choose 0, which is 1, x to the 0, which is 1, and 2 times 0 minus 1, well, it's just negative 1. So the first term here is negative 1. That's going to cancel out that 1, and I could just start this series at 1. Same series. Okay, so what's this going to be? Well, let's see what to do next. I could bring this in. So I'll get an x to the n minus 1 over 2 times 2n minus 1. I feel like we're close. So what do we want? Well, we want to get the coefficient of x to the n. What do we have? Well, we have everything written in terms of x to the n minus 1. What could we do? Well, we could re-index this. I could just replace n with n plus 1, and as long as I do it everywhere, I'll be fine. So let's do that. That would give me n equals 0 here, and I'm going to get a 2 n plus 1 choose n plus 1 x to the n over, now if I replace this n with an n plus 1, well, that's being multiplied by 2, so I'm going to get 2n plus 1 down there. Okay, now let's write out what this is exactly. I'm going to have in the top a 2n plus 2 factorial. This is still in my sum. And in the bottom here, I have n plus 1 factorial, n plus 1 factorial, 2 times 2n plus 1. Okay. Well, let's try to simplify this just a little bit. I can make this 2n factorial, 2n plus 1, 2n plus 2. See, then I'll get a 2n plus 1. And in the bottom here, I could rewrite this as n factorial, n plus 1, n factorial, n plus 1. Okay? And then what else do I have? I have a 2, and I have a 2n plus 1, and I have an x to the n in the top. Now this is very nice, because I have a 2n plus 2 right here. That's a 2n plus 2. So I can cancel that with these two. And I have a 2n plus 1 right there. And what does that leave me with? It leaves me with n equals 0 to infinity of, well, I get a 2n factorial over n factorial. That's 2n, choose n. And I have a single n plus 1. So I get a 1 over n plus 1 times x to the n. And I know that the Catalan numbers are given by the coefficients of x to the n. And what are those coefficients? They're right here. So I finally get Cn equals 2n, choose n, times 1 over n plus 1. And I have solved for not just one, but for all of the different problems I've showed you, whether it was binary trees, or finding ways to make parentheses, or the number of paths up a triangular lattice, or triangulating a polygon. They all have this same answer, and this sequence is called the Catalan numbers. Of course, originally created by a Chinese mathematician named Ming, because none of these sequences are actually named after their creators. But Catalan did discover it later. So that is a nice example of, finding a way that we can count all of those things at once.